One day, the king of Monarech received a note from his cousin, a king in the distant land of Cardanum. Dear cousin, I would like to congratulate you for winning the archery competition that was held in my castle last week. I reward your outstanding performance with 11 gold coins. The coins are equally divided into these 2 sealed pouches. If I'm to receive 11 coins cannot be equally divided into 2 pouches. I almost forgot the pocket change. The king ran out of sealable pouches. But how do you know the coins are equally divided in those pouches? The pouches are sealed. Nobody can see how many coins they contain. I was told that each pouch contains the same number of coins, and I was assured that all 11 coins are there. We'll see about that. Can you figure out how many coins are in each pouch? How can a visual equation help you? So as you can see, I have 3 more examples like what the king just shared. This is not in your notes packet, so all you need to do is watch these 3 examples. When you're done, go ahead and grab the practice off the shelf. There's 5 that look like this for the practice worksheet. Okay, but this is not in your notes. All we need to do is just watch these couple, and then I would leave them up as a reference for when you go to try the worksheet on your own. Okay. In my first example, I was supposed to be given 10 gold coins for winning my competition. However, they brought me 3 sealed pouches and some pocket change with 4 extra coins. So right now, I don't know if a pouch contains 1, 2, 3, however many coins, but I do know that they are even in each pouch. So if this one had 1, this one would have 1, and this one would have 1 as well. So our job is to figure out how many coins are in this pouch. So my first step is I have some extra pocket change over here. So in order to figure out what's left over for my pouches, my first step is I would subtract my 4 extra gold coins. That leaves me with 3 pouches. If I'm to have 6 coins for 3 pouches, my next step is to divide by 3 pouches. So in this picture, each pouch contains 2 coins. Okay. Here's where it gets a little trickier. Our goal is to make an equation for this unit. So when I started off, I saw 10 coins, and that equaled 3 of my mystery pouches plus 4 coins. So when I said my first step was to subtract 4 coins, in my equation, I'm going to think of it like a balance beam, I minus 4, and I show those steps on both sides just like what I did here. If I subtract 4 coins from one side, I subtract 4 coins from the other side. That left me with 6 coins for 3 pouches. And then I divided by 3 to figure out how much was in one pouch. So I cut it up into 3 groups, but again, I showed my steps with a divide by 3 on both sides. So my pouch is worth 2 coins. My last step is to check my answer. So in this equation, does 10 equal 3 times 2 plus 4? Well, 3 times 2, if each pouch had 2 coins, that would make 6, plus my 4 pocket change. Yes, he did get paid his full 10 coins. All right, in this next example, I see 2 pouches with 4 coins equal to 1, 2, 3, 4, 5, 6 times 2, 12. So I was supposed to be awarded 12 coins, but instead they gave me 2 pouches with 4 extra coins. Now this picture is set up a little unique. It's actually 2 separate things that match. So I can do that same thing over here in my picture. So my very first step, I can divide into 2 groups. So then I'm left with this pouch and 2 coins is worth the same as this 6 coins over here. This pouch and 2 coins is worth the same as these 6 coins over there. Then I'm going to repeat my step like last time. If I have 2 extra and I want to figure out what's left, those 2 are with the same as 2 over here. So I'm going to go ahead and subtract 2 from both sides. And that leaves me with 1 pouch is equal to 4 coins. So over here in my equation, this is actually set up with the distributive property. So I have 2 groups that were the same thing. So I'm going to use a parentheses. I had 2 groups that each had a pouch plus 2 coins. That equaled 12 coins. If you would like to distribute first, you can. I could take 2 times p and get 2p. I could take 2 times 2 and get 4. But then I'd have to subtract 4 coins on both sides, and then I would have an extra step of dividing by 2 at the end. So this works to distribute, taking both times 2. It's just going to make a little more work for you at the end. Since everything on this side is in my parentheses, that's what made it okay. My very first step, I could go ahead and just divide by 2. That would leave me with a pouch plus 2 equals 6. And again, thinking of it like my balance beam, instead of adding 2, I can subtract 2 from both sides, leaving me with a pouch equals 4 coins. Okay. Over here, my check step, I have 2 groups of 4 plus 2. So order of operations tells me that I would do 4 plus 2, which is 6 first. And then 2 groups of 6 does make my 12 coins. So when I get to that check step, I'm going to go ahead and copy this same equation down. And since I said my pouch equals 4, I'm just substituting that right in there where I see my p. Okay. Just know it does work to distribute. So you could also say 2 times p, 2 times 4, but then you're just going to have an extra step there compared to me. You should still get the same answer, though, of a pouch is worth 4 coins. All right, my last one we're going to look at here. I have 3 pouches, and that equals 2 pouches plus 1, 2, 3, 4, 5, 6 times 2, 12 coins. So this time, instead of subtracting coins, because I don't have any coins over here to get rid of, I can subtract my pouches from both sides. So if I take away 2 pouches over here, 2 pouches over here, subtract 2 pouches, that leaves me with 1 pouch for my 12 coins, and I actually already have my answer. In my equation, it would look like this. 3 pouches equals 2 pouches plus 12. So since I don't have any parentheses, there's nothing to distribute or multiply, I'm always going to start with that subtraction first. I have a list of things, so I'm subtracting from both sides what's in common. Since my pouches were the same, that's what I subtracted this time from both sides. That leaves me with 1 pouch equals 12 coins. Okay. If I had coins from both sides, I could subtract coins from both sides as well. And then be careful, if you end up with more than 1 pouch at the end, my last step will be to divide. Okay. Also, don't forget that check step. So 3 times, I think a pouch has 12 coins, is supposed to equal 2 groups of that 12 plus an extra 12 coins. So on this side, 3 times 12 would give me 36 coins. On the other side, 2 times 12 is 24, but I did have an extra 12 of pocket change. So 36 does equal 24 plus 12. So yes, that works out. On your exit slip for 2-step equations, you will see that check step. So try and get in the habit of, even if it's mentally, still putting it in and make sure it works. Okay. All right, so to summarize, before you go try some on your own, the first step is when I write this equation, count up my number of pouches, count up my number of coins. It doesn't matter which side the pouches are on or the coins, but make sure you have a P for each number of your pouches. Then, if I have a group that matches, I can divide, but typically your first step is going to be to subtract from both sides. I cancel out coins from both sides, and I can also cancel out pouches from both sides. My last step is if I have multiple pouches, I need to divide. Go ahead and grab the worksheet. It should have 5 examples that look similar to this, but there's different number of pouches and coins. Feel free to leave this video up though as you're working so you have a reference to go off of.